Hi everyone, today I have come up with a new topic. As you can see over here, the interrupt. So during the demonstration of architecture 8085 microprocessor, we have encountered with this interrupt control block that we have seen this block there also. So as you can see here, I have drawn this interrupt control block as well as I have drawn the 6 hardware pin connected to the interrupt control block. Out of this 6 hardware pin, 5 hardware pin is called the interrupt pin, and one is a interrupt acknowledgement pin. Interrupt acknowledgement pin. This one is the interrupt acknowledgement pin. So by this hardware pin, by this 5 hardware pin, microprocessor gets the interrupt request from the externally input output device and will process those interrupt requests. But one thing, at a time microprocessor can process one interrupt request. So that was the 5 hardware pin. So now let's comes to our next, this pin, which is the interrupt acknowledgement pin that you can see over here. So what is the use of this pin? So when microprocessor is performing the request of any interrupt request, at that moment microprocessor will send a message to the input output device which is connected to the microprocessor externally. So it will send a message to externally input output device that microprocessor is not available to take any more interrupt request at that time being. So by this request will be sent over to that external device through this interrupt acknowledgement pin that you can see the direction. This direction is from the microprocessor to the outside pin, from the microprocessor to the outside device. So that were the basic description about this block. So while ago I was continuously taking the name of one particular word, which is interrupt. Interrupt. So this, what is the mean of an interrupt? What is the mean of interrupt? So let's first define the interrupt here. So as a general definition, if we will make a general definition, then I would say interrupt an interrupt is a signal to the processor. An interrupt is a signal to the processor given by the externally device indicating an event that needs immediate attention. Let me just write it, then it would clear to you. So an interrupt is a signal to the processor given by the external IO device indicating an event that needs indicating an event, which event? Interrupt request, an event that needs immediate attention. That means whenever the microprocessor will get that interrupt request, it will start to perform the interrupt operation. So an interrupt is a signal to the processor given by the external IO device. Always the signal will be given by the external IO device indicating an event. An event, that means an interrupt request, an event that needs immediate attention. It will not wait for a time. It will not wait for a while. So let me give an example. Suppose you were performing or you were doing some work at your home. Your friend come to your home from the outside, and first you stop the work that you were doing, and then you were busy with your friend by some any kind of work like some gossiping, and then when your friend went on from your home, then again you started the work that you were doing. So that means your when you are in a process, when you were doing something at your home, your friend came to you and interrupted with you and your work. Then you just go approach to your friend, you took a approach to your friend and did some chit chat with him, and then you came back to the process what you were doing from the first. So that is the interrupt. Same thing, suppose microprocessor is performing a program, and when interrupt request will come to the microprocessor will stop all its execution, then perform the interrupt request first, and when the interrupt request will process, then microprocessor will come back to the main program or the process what it was performing from the first. So that's the interrupt or interrupt control block, but we will discuss about this thing in our coming session in detail, and that will clear your idea. So that were interrupt, and it was interrupt control block. So let me see some features related to this interrupt. So first feature is it is a asynchronous data transfer process. So what does it mean? Have you ever heard the term asynchronous? You have. When we were talking about the ready signal, we heard the term synchronous. So this asynchronous is the opposite of synchronous. So what does it mean, synchronous? Synchronous means, suppose if microprocessor wants to transfer some data to the input output port or the vice versa, so data transfer will possible when the speed of the microprocessor should be synchronized. The data transfer will possible when the speed of the microprocessor will be synchronized with the speed of the IO device. At that moment, IO device will able to transfer the data microprocessor, and microprocessor can complete the data transfer process. That means that to transfer the data, microprocessor and the IO device should be synchronized in speed, and here the term is asynchronous. That means it's the opposite of synchronous. So then in this process, in this interrupt process, microprocessor shouldn't be synchronized with its speed to the IO device speed. So it is not recommended, or it is not the obvious one. So that means that if the speed will not be synchronized, that means it will also not depend upon the time. So that is an asynchronous device. So without synchronizing the speed of microprocessor and the externally IO device, the data transfer can be possible by this interrupt control block that I have also told you before. So, and this is a asynchronous data transfer process, as well as I have told you it will be time independent process. It will not independent process. So that is the thing. So our second feature is that the process start from the IO device. What does it mean? That means when the IO device is ready to transfer the data to the microprocessor, at that moment it will send the interrupt request to the microprocessor. So that's why the pin all are inward to the microprocessor, that you can see all the 5 pin. So that's why it has said here that the process start from the IO device always. And third feature is, it's so important, Suppose microprocessor has got some interrupt request. Then how does it process those interrupt requests? How does it process? It processes those interrupt requests by executing an interrupt service control. It will process those interrupt requests. Let me write. It will process those interrupt it will process those interrupt requests by executing an interrupt service routine. That is a very important thing. It is called the ISR, that you can say, interrupt service routine. So whenever microprocessor will get some interrupt request, first it will process the interrupt service routine. What is the interrupt service routine? Just I am giving the little bit of brief introduction about ISR. We will discuss in detail what is ISR. So just remember the term ISR, interrupt service routine. Mainly, or basically, it's a program which is written in a specific memory location for individual interrupt. So that means that each and every interrupt has its own ISR. It's a program which is written in a specific memory location for every interrupt request. That means whenever every interrupt request wants to execute, microprocessor wants to execute every interrupt request, that microprocessor should be execute the ISR which is written in a specific memory location. That means that each and every interrupt has, that means that each interrupt has its own ISR, interrupt service routine. So important thing about the interrupt. So that were the some features about the interrupts. So next question is, what are the different type of interrupt available in 8085 microprocessor? So let me first erase those things. This thing, there are interrupts can be classified in three ways. First one is a hardware and software interrupt. Second is a maskable and non-maskable non-maskable interrupt, and third one is a vector and non-vector interrupt. So these are the three way. That way we can classify the interrupt. So hardware, software, maskable, non-maskable, and the vector, non-vector. So now let's start the discussion one by one. So first we will discuss the hardware and software interrupt. So let me first discuss this first one. So what is hardware and software interrupt? Hardware interrupt. hardware interrupt. So there are 5 hardware interrupt available that we have seen. There are 5 hardware interrupt available in 8085 microprocessor. These all are the hardware interrupt. There are 5 hardware interrupt available in 8085 microprocessor. What are they? Trap, RST, register 7.5, RST 6.5, RST 5.5, and INTR intra. So these are the 5 hardware interrupt available in 8085 microprocessor. So what are the software interrupt available in 8085 microprocessor? There are 8 software interrupt available in 8085 microprocessor. There are 8 software interrupt available in 8085 microprocessor. What are they? Do you know? They are RST, or you may say REST, ART, restart, full form of RST. RST-N, RST-N, N equals to, N signifies 0 to 7. N signifies 0 to 7. That means first software instruction is RST1, RST0, RST1. In that way, RST2, RST3, RST7. So that is our 8 software instruction. So that's the basic thing about the hardware and software. So in our next session we will talk about the maskable, non-maskable vector and non-vector interrupt.